Let us hit it off with what I've put together different sections to help you with exam-related questions. Let's start off. Okay, I'm starting off. I've picked up some few questions on simple and compound interest. Most of the questions, they are almost similar. It's just the context that will change. So what we are doing is just to say, in any question, what are the things that, how do you break down the question so then you can be able to answer it the way that it's supposed to be answered. So let's look at this question whereby what is the present value? Obviously here, what you do is to break it down into pieces and write all the information that is given. So they are asking for a present value, okay, of a loan on the 5th of May, okay. If it accumulates to this amount, the accumulation amount, that is 4,500. Okay, and then you are also given the time, okay, on the same year. We are working with the same year at a simple interest rates. So you know that you are working with simple interest. So you know you are going to be getting the formula of the simple interest, which is 0.15, and you are given the time, okay? The time is, you are given the days, okay? So now what you need to do is to calculate the days, okay? You calculate the days that are between 5th of May and 16th of August. So now what you do, you say 5th of May, then you're going to look at this. You are looking for 5th of May. So there is 5th of May. 5th of May is 125. So you've got your 125, and you are also looking for 16th of August. 16th of August is here is 228. So now you are going to have those two values and subtract them. And then since you are working with days, remember, if ever the time that you are given is less than a year, you would have to put it as a fraction. So since these are the days that you are working with, so you need to divide by 365. So here you have got 5th of May. We said now the 5th of May is 5th of May is 125. Okay, and then you've got 16th of August. 16th of August, when you look from that table, it is 228. So therefore, your time is equal to 228 minus 125, which is equal to 103. However, you know that you are working with these are the days, okay? So now these are the days that are between these two dates. The days between these two days is 103. Since you're working with days, you're going to divide by the unit of the days in a year, that is 365. Okay, so that was the only thing that was highlighted by this question. So you know the formula for the simple interest. The formula for the simple interest is equal to P into 1 plus RT. You are given the accumulated amount. Okay, you don't know the P, so you've got 1 plus your R. You know your R is 0.15, and the time is 103 over 365. Okay, once you've got this formula, you can plug it into your calculator, rearrange everything. So therefore, you're going to get that your P is equal to 4317.26. So this question, the only thing that it was, the critical aspect was the one of the days. Okay, so you don't need to be scratching your head. Go to that table that you'll be given at the back of the formula sheet, go and calculate the number of days. And then because it is the days, you need to divide by 365. Okay, I will also highlight how you use these days when you are working with the bonds. okay? Because there's a special way of working with the bonds when you are looking for the number of days, okay? So let us look at the following question. So this following question, you are requested here to, you are told that Lulu wants to buy a television set that cost, this is the cost, okay, which you can view it as the present value. That's how much, that's the value, the current value. So this means this, your P is equal to 3,500. This is 3,500. And then she approaches a bank which agrees to lend her the money, pays the loan in 10 months' time. Here's another aspect here. You are given the time in months, so you've got 10. I'm going to write months just on the side, so then you know that you need to divide that, you need that time to make it a fraction by 12, because these are the months. So we know our time, we're going to divide it by 12. And then what is the size of the loan should she apply? What size loan should she apply for if the bank charges 13%? Okay, so now the amount that she applies for, that means it's the amount that is going to be in the future. So if the bank charges the 13%, so now your I is equal to 0.13, and then the bank, the discount. This thing is a discount. This is a discount, isn't it? The bank charges 13% bank discount. So this is a bank discount. It's not an interest. Okay. So what is given here? We are looking for S. You are given P. Okay. You are looking for S here, because now they are looking what size of a loan should she apply for if the bank charges 13%. So now we are looking for S. Okay, so that is the S that we are looking for, because we are working with a discount. So that is the S that we are going to be calculating. Remember, the discount is calculated on the future value. So now you just get the formula for the future value. So the formula for the future value, it is P is equal to S into 1 minus dt. Okay, so your P there, it is 3,500, which is equal to S into 1 minus your discount, it is 0.13, multiplied by here, you've got this time, which is 10 over 12. So 10 over 12. So this was pretty much straightforward. Okay, so you don't need to be, you don't think that much here. So these are the questions that you just need to get them straightforward. You don't need to be stressing and overthinking. There's no timeline that you even need to be stressing yourself with. Okay, I'm not saying that if you want to write a timeline, you can write it, but there's no need for a timeline here, because the question is straightforward. Okay, what is an equivalent simple interest here? So now the equivalent simple interest, okay, the equivalent simple interest. Now you are looking for an equivalent simple interest. Okay, so there are two ways that you can calculate this question, but remember, you want to be saving time. You don't have time of going the long road. But if you don't have, you don't know how the shortcut, you can just go the long route. I'll show you the two methods. So here you're going to have R is equal to D over 1 minus dt. Okay, you are looking for the R. The discount, it is 0.13. 1 minus the time there. Your time was given as 10 over 12. That's what you have concluded. 10 over 12 multiplied by the discount of 0.13. Okay, so now this, your R is going to give you 0.1458. Okay, should it happens that you don't remember the formula for an equivalent, an equivalence between simple interest and the discount, what you can do here, would be for you to go and calculate the interest. Okay, you would say, okay, fine. I know from here, I've got my S. Okay, I've got my S, I've got my my present value. I can calculate my interest, the actual interest amount. So I know the actual interest amount is equal to my future value that I've calculated, 3925,23 minus my present value, which is 3,500, and then I get the answer. Okay, then I get the answer of 425. The answer of 425.23. Then once I've got my interest, I know my simple interest formula. My simple interest formula is equal to PRT, because now I am moving between the discount and the simple interest. So after I've calculated my interest, I know my interest is 425.23. I know my present value, it is 3,500. I don't know my R, that's what I'm looking for. The time is 10/12. Okay, this implies that if you make R the subject of the formula, you find that your R is 0.1458. It is really up to you. Where is your mind? Sometimes you forget the shortcuts. Okay, so I just wanted to show you that you can also get the answer by first calculating the actual interest, not the interest rate, the actual interest. So let's look at another example. This example, okay, this example, Mario has been given an option to either pay his bill. Okay, he can either pay his bill, his 2,500 bill now, okay, or settling it later, okay, after 4 months. If he chooses to pay after 4 months, the simple interest rate which he would be charged is, okay. So now when you look at this question, this 2,500, okay, this 2,500, this is a simple interest formula. So the simple interest formula is equal to P into 1 plus RT. Okay, this, your P is equal to, is an amount that he can pay now. That is a present amount that he can pay now, or he can decide to pay it in the future, which is 7,030. And then the time, you are told that the time is 4. Remember, when the time is 4, it's months. So now you have to divide by 12. Okay, so now you can just substitute everything there, which is 2,730, which is your P. Your P is 2,500 into 1 plus R. Okay, it is R, your T, it is 4/12. So this is the similar, this is the same process as we have done the previous one. Okay, so your I there is equal to 27.6%. If you don't like this method, you can just go and calculate the actual interest. Okay, calculate the actual interest by saying, I know that the interest is equal to the future value minus the present value. Okay, and then after you found the interest, which is 230, you now go and calculate and use the formula of I is equal to PRT, which is a simple interest. Okay, your I is 230, your P is 2,500, and then that's what you're looking for, your R, and then your T is 4/12. So if you rearrange everything, you'll find that your R is equal to 0.276. Okay, so this question is similar to the one. So I'm exemplifying using similar questions, but in a different context. So let's go and have a look on the annuities. Okay. Let's have a. I think we have exhausted our compound interest. If ever you still have issues with compound interest, you can ask for a one-on-one consultation, so then I can help you with the compound interest. The reason why I have not put out the compound interest is because we'll be using compound interest when we are doing our annuities and other aboma amortizations. So it will be a waste of our precious time. So let us look at some questions on annuities. Okay, so if you have, it's the first time that you are attending this, then please pay attention. If you have exhausted everything on annuities, please you can like engage with us and help us with some of the issues that I may not have attended to. Okay, so now I am looking at annuities. Okay, know what are the formulas that you are working with. Remember, there are different kinds of annuities. You've got the deferred annuity, you've got the annuity due, and then you've got ordinary annuity. Okay, the ordinary annuity will be the one that is paid at the end of the month. The payments are paid at the end of the period, maybe monthly or quarterly, at the end of the month, end of the quarter, end of the year, depending on the time. If ever is an annuity due, you are making a payment at the beginning of the period. Okay, and then if ever you are making if ever I said deferred, you've got two periods. One is when you are deferring the payments, and then the other is the period whereby you are making payments. So you are working mostly with the timeline. Okay, so let us look at this question. So then we can highlight things that you need to watch out for when you're answering these questions. So what is the present value? You already know the discourse around this question. It is about payments. The minute you see payments, you know what you are working with an annuity. So now what is the present value? You are asked for a present value, okay, of the payments of 250. So now your payments equal to is 250, okay, made at the end of every quarter. It's made at the end of every quarter. Yeah, so your payments are made at the end of the quarter. So you know that the compounding periods is 4 when it's quarterly because of every quarter. That means that these payments are made at the end of every quarter. And for 12 years, you are told that your T, okay, your T is equal to 12,5. Once you've got this and that, this implies that your N is equal to MT. So your MT, it is 4 multiplied by 12,5. Okay, which is equal to 50. So you are done with your N because that's the formula that you need for your present value. Remember the formula for your present value, it is P is equal to RANI. So this is the formula that you are working with. Okay, so you are like trying to break down all the information that is given, and then you are told that the interest rate, here is your interest rate. Your interest rate is equal to 0,075. Okay, however, this thing, okay, I'm putting a star. It is compounding semi-annually. It is compounding semi-annually. We've got a problem. Okay, watch out for that. You have got a problem if this compounding period of your interest, if this is not the same as this, you've got a problem. They need to be the same. Okay, so if they are not the same, you need to get out of here and go and convert this interest, convert it into quarterly. Okay, convert to quarterly. Okay, so now to convert it to quarterly, you need to use a formula for converting to quarterly. So you'll be converting this interest to quarterly. It is an interest that is semi-annually. You want to convert it to quarterly. So now we are going to be using a formula which is saying Jn is equal to n into 1 plus Jm. That will be the current interest that you are given with is compounding. So I'm going to put star here. This is the star. This is the interest that we are working with here. And this is going to be m over n minus 1. This is the formula that you use to convert between nominal interest rates. Okay, so now you want to convert to your n. You want your n here to be equal to 4 because you want to convert to quarterly. So now you've got 4. Okay, I'm going to put 4 here. To 4, this is going to be equal to 4 into 1 plus J. Your Jm is the interest that you are working with, the one that you want to convert, which is 0,075. Okay. This interest, it is compounding semi-annually. So you've got 2. Okay. You've got 2. What is your M? Your M is 2. What is your N? Your N, it is this value, which is 4 minus 1. So this is going to give you the new interest rate of 0,07431. Okay, so now this is your new interest rate. So now this is the interest that you are going to be working with. You are no longer going to be working with this one. You have already converted it. So your new interest rate now is going to be equal to 0,07431. Okay, so once you've got that, you are ready to go to your formula. So now your P is equal to your R is 250. Your A, your N, you've already calculated your N. It is equal to 50. Okay, what is your I? Your I, it is this one, which is 0,074. It is compounding now quarterly. That's what we have done. So now you are going to be dividing that by 4. Okay, so because everything, the payments are done quarterly, even your interest, it is compounding quarterly. So you get this in your calculator, and then you get that your present value is 8096,11. This question, what it is highlighting is your compound interest is compounding in different periods. It's compounding semi-annually. The payments are made at each and every quarter. So now they need to be the same. The time periods that you are making payments should be the same as the time periods as your interest. Okay, so you have to do something with your interest. So because this was semi-annually, this is what we have done to convert it. Okay, after you have converted it, you still need to divide it in your formula by 4. Okay, why am I highlighting that? Most of the time, people, after they've calculated this, they don't see a need for dividing it again in your formula by 4. Okay, you still need to divide it by 4. Okay, that is very important. Yeah, Bo.
How do you punch in that formula on your financial calculator HP10 B11 plus?
Sure. Is it? Don't you have it on your notes on how you go through your different calculators?
I don't see it.
Look on your notes. What Adele has done, she has put 2 different calculators that you are using to help you on how you can use different calculators.
Oh, okay.
It is in your notes. If you think that you cannot follow the notes, go to YouTube and enter the calculator name and what you want it to help you to calculate. So then you can see how you are doing these calculations in your own calculator.
Okay, ma'am. Thank you.
All right. Okay. This is a question on annuity, deferred annuity. To make it smaller, it's too much. Okay. A deferred annuity, you've got two payment periods. So you need to be able to draw your timeline. Okay. So now you are told about this guy. He is like now, the current moment, he's 33 years old. Okay, he has just received an inheritance from his parents. He said he wants to invest an amount of money today. Today he's 33 years old. He wants to invest that money such that he can receive 5,000. This is your R, 5,000 at the end of every month. Okay, so this is an annuity. End of every month is the payment. End of every month, it is suggesting that you are working with your ordinary annuity. Okay, because the payments, the 5,000 payments are made at the end of every month for 15 years. So the annuity is going to run for 15 years. Okay, he wants to start doing that. He wants to start getting these payments when he retires at the age of 65. So from age 33 until 65, he is not getting any payments. He starts getting payments after 65 years for 15 years. Okay, so now we are told different interest rates. So there's an interest rate that he can earn when the investment is compounding annually. That is before 65. There is no payments, so it's the normal investment which is compounding annually, and then after that there is another amount that is getting the 5%. It is also annually when the fund is paying out. Okay, how much money must he invest today? So they are looking for the present value. Okay. Okay, we need to calculate the present value, not the present value of the ordinary annuity, but the present value that he wants, the money that he wants to invest today. So we need to have, we need to calculate to have a timeline. Okay, our timeline is going to have, he's now he's 33 years old. Okay, he is 33 years old now. Okay, we are looking for the present value today now, so we don't know the present value here. Okay, so this is just a normal investment. It's a normal investment. The only time he's only going to start receiving the annuity at the age of 65. So this investment is going to be running between 65 and 33. So the time of this investment, it is 65 minus 33. Okay, I'm going to say 65 minus 33, which is going to be equal to 32. That is the time of this investment. Okay, this lump sum. And then we are told that this is going to earn 9% compounded annually. So now the interest rate here is going to be 0.09, and we are told it is compounding annually. So your M is equal to 1. So that is what is happening during the first 32 years. And then you are told, after this, okay, after 65, now his investment starts paying. It starts paying aboma 5,000. Okay, aboma 5,000. Okay, it's paying aboma 5,000 until he is age until he retires. When is he retiring? I don't know, but you are told that between here, okay, and between these periods, okay, until here, Between here until here, you are told, Guti, this is 15 years. Okay, that's what they are saying, Guti. Each and every month after 15 years, he's going to be getting these payments. Okay, and another thing that you are told about this period, you are told that your I during this period is equal to 5%, and it is compounding annually. Okay, it is compounding annually, but now the payments are being made at each and every month. So now you've got your payments of 5,000. Okay, your payments of 5,000, they are compounding monthly. It's very important. They are compounding monthly. However, the interest rate, I'm going to put a star, is not compounding similar time as your payments. It's a problem. If you compare the question on the previous example, it is saying the compounding periods of your payments need to be similar as the compounding periods of your interest rate. So we need to convert this interest rate using this similar formula, okay? Using this similar formula, so then we can get the interest rate that is compounding the interest rate that is compounding monthly. So now you need to go and calculate this using that formula. I'm going to put it on the side here. Let me get a different pen. Okay, so now we are going to have J12 because we want to convert this thing to monthly, because this is what the payments. We are not going to change the payments, compounding periods, but we can change the interest rate. We can convert it using the formula. So now we are going to have J12, which is 12 into 1 plus the interest rate that we want to convert is this one, which is 0.05. It is compounding annually, okay? And then we're going to have 1 divided by 12 according to the formula of converting between two nominal rates. So this is going to be -1. Okay, so your new interest rate there is going to be equal to 0.0489. So this is your new, you are no longer going to use this interest rate. You are going to be using this one, which is compounding monthly. Okay, once you've got that, now you can go and do the calculation of this period. You've got two calculations. We are working with this period first. Okay, so we are here, and then here we need to calculate the present value. It's an annuity. So now we are calculating a present value of an ordinary annuity. I'm putting ordinary so then you can see the difference. It's ordinary. Why is an ordinary? You are told it is end of every month. Okay, so this is going to be equal to RANI. Okay, so your R, you know what the payments is 5,000. Okay, A, you are told Guti, this thing is going to be running for 15 years. We've got our 15 years there. So you've got 15. The interest rate that was given here was compounding at a different compounding period. So we needed to convert it. So hence we are going to be using this one. So now the interest rate, it is 0.0489. Remember, you still need to divide it by the number of the compounding periods that you are working with. That is 12. So you're going to divide it by 12. Okay? So therefore, your present value is equal to the present value of your ordinary. Let me write it here. The present value of your ordinary is going to be equal to 636, okay, 925, okay, comma 79. Remember, the present value of your annuity, it is the value here at the beginning of your annuity. Okay, so your PV ordinary at this period, Okay, it is a future value of this. Okay, it becomes a future value. It becomes a, let me have this. It becomes a future value. It is a future value of this investment. At the end, whatever you are going to get here becomes the present value of your annuity. So now the future value here is the same as your PV on ordinary. Okay, so now this amount becomes also the future value of this investment. Okay, this is a normal investment, so we are going to be using a formula of PV of future value. Okay, we want to calculate the future value, so the future value is equal to present value into 1 plus I. Okay, it's the normal compound interest investment. It's not an annuity. You know that your future value at this point is the same as your present value of your annuity. So you are going to have your 636, okay, your 636,925.79, okay. What is your present value there? Your present value is what you are looking for. Okay, 1 plus, you are told what the interest rate there is different. It is 0.09. Okay, it is compounding annually. I don't need to be dividing or doing anything. And then this is to the power. What is your n or your t? Your n is equal to 32. So you're going to have your 32. So therefore, your present value of the amount that is supposed to be investing now, it is going to be 40,000. Okay, 405. Okay, 405.54. So when you are working with your deferred annuity, you are going to be focusing on 2 periods. So you need to write your you need to write your timeline, so then it can give you an idea what is happening. But most of the questions on a timeline or on a deferred annuities, they are almost the same. Okay, so let me give you another example. Let me look for another example whereby you are working with the deferred annuity, because you are likely to get a question on deferred annuity. You are likely to get it. So let's see. Let's get another question. This is the question. Okay, so here's a question. Okay, this question is saying a businessman buys 100,000 equipment, okay, in the following terms. Okay, interest will be charged at a rate of 12% per year, compounded semi-annually, but no payments will be made until 2 years after the purchase. Okay, thereafter, equal semi-annual payments will be made for 5 years. Okay, now let us get our timeline so then we can have an idea of what is happening. Because now we are talking, you can see it's a deferred annuity. You are deferring the payments. So you are starting off here. Okay, you know, with your deferred annuity, you've got two parts. It is this part and that part. You've got a deferral period and the one whereby you are getting the payments. Okay. Here you are given the present value. Your present value is given as 100,000. Remember, on the previous question, the present value was not given. You needed to calculate the present value. Now you are given the present value, and then you are told that the interest here is equal to 0.12, and then you are told it is compounding semi-annually, so your M is equal to 2, okay? And then you don't know, unfortunately, you don't know your future value here, okay? You don't know the future value of this. You only start to pay, and then you only start making payments after 2 years, okay? So now your time here is equal to 2. Okay, remember, if ever you've got this implies that your N is equal to MT, so which is equal to 2 times 2, which is equal to 4. So now you've got all the information for the deferral period, whereby you are not making any payments. Okay, so now let us look on what is happening thereafter. Okay, thereafter, equal semi-annual payments will be made for 5 years. Okay, remember, if you read your notes, if the question is not specifying whether you are making payments at the end of the month or you are making payments at the beginning of the month, like this question, the assumption is you are making at the end of the month. It's an ordinary, okay? Because this question is not saying you are making payments at the end, okay? It is just saying you are just getting equal semi-annual payments. So the payments are made semi-annual. So now you've got those payments here. Okay, you don't know those payments, but they are made semi-annual. You don't know those payments, okay, for 5 years. So from here, okay, from here until the end, let me get a different pen. So we are looking at this part, okay? At this part, the time there is equal to 5, okay? However, you are told, Gucci, these payments are made, for this period, these payments are made semi-annual, which implies that your N is equal to 5 multiplied by 2, which is equal to 10. That's the information that you are getting here. And then the interest, it is just it is for the whole period. So the interest here is equal to 0.12, and then it is compounding semi-annual. This is compounding semi-annual. Okay, so in this instance, we are happy. Okay, we are happy that we are happy that we are happy that this is the same as this one, so we don't need to be converting anything. So now here we need to calculate our R. We don't know our R. Okay. So now, if ever you can compare this question with the previous question, for us to be able to calculate our R, okay, we can get this. We need to get this future value. We know what this future value is the same as the present value of the ordinary. Once we've got the present value of the ordinary, then we can use the formula of the annuity. So now we are moving backwards. We need to first calculate the future value of the 9 payment period. Okay, so let us get the present value here, the future value. Okay, the formula for the future value is equal to present value into 1 plus I to the power n. Okay, we don't know the future value. That's what we are looking for. So the future value is equal to the present value. That's what you are given. It is 100,000 into 1 plus our interest rate. It is 0.1 0.12. Because it is compounding semi-annually, we are going to have divide by 2. Our n, we've already have our n is equal to 4. Okay, then we are going to get that your future value is equal to 126,247,70. Remember, this amount is the same as this amount of the present value ordinary. So once you've got that, you say, okay, fine, let me go now to my annuity. Okay, you go to your annuity and say, now I am working on these periods, okay? I am here. I am working in this period. I've got the PV ordinary. So now I've got my PV, which is equal to RANI. Okay. What is your present value? That's what we have just calculated. Your present value, it is equal to 126. It is the future value of your non-payment of your investment, which is 126,247,70, which is equal to, you are looking for your R, you don't know your R, okay? What is your N? Your N here, that's what we have calculated for this period. This is a period that we are looking at. For a period which is 10, and then your I is 0.12. We don't need to be converting anything here because our compounding periods are similar. Okay, the payments are made semi-annually. The interest is made also semi-annually. So you are going to have your interest of 0.12 divided by 2. Then you are going, therefore your R, when you plug this thing in your calculator, your R is going to be 17153,2. Okay, so now this will be your answer. So what I've done here was to contrast two examples. Okay, one example, you don't know the present value. Okay, you don't know the present value of your normal investment. That was the previous, this example. Okay, in this example, we did not know this present value. We needed to start from this side and move backwards to get the future value, because the future value is the similar as this one. After getting the future value, we came to this formula. But in this case, okay, in this case, we were given the present value. We are looking for the R. So we needed to start from the beginning going forward. Okay, so I've contrasted those two examples. So then you can see how to manipulate. So the issue here is manipulating these the components of what you are given. Okay, so that is mostly the questions that you can expect on annuities. The deferred annuity, do expect a question on deferred annuity. Okay. The ordinary, I mean, I've given you a revision on how to calculate an ordinary annuity. This was the part of that. And I've also done a revision on how to calculate the compound interest. Here is on how you calculate the compound interest with so many compounding interests. So there were so many revisions on one example. Okay, so let us look on examples that are looking at amortization. Okay, the amortization, you know, the reason of amortization is about payments. You're making payments, equal payments at specific intervals, but you need to be paying the interest together with the principal at the same time. Okay, so the formula is mostly like this one. Okay, we are looking mostly for the payments. The payments, this is the formula for the payments. It is coming from here. Okay, so let us look on the questions on amortization. Okay, so now again, the what is important is read what you are given. Okay, is to read what you are given. Okay, Megan is about to purchase a car. Okay, and is considering borrowing the full amount from the bank and repay the loan in equal monthly payments at the end of each month. Okay, for 44 months, okay, at an interest rate of 15% per year, compounded monthly. We need to remember the formula for what is this? We need to calculate here. This is it's more like it's an amortization kind of a question. So we need to first calculate. We are asked to calculate the size of monthly payments. We don't know our R. Okay, so we know that the formula is P. I want to save space. So you've got P is equal to R A N I. Okay, so now that's what we need to be calculating. We are given, what is it that we are given? We are given that our P is equal to 191,810. Okay, we know what is our P, and then we are told our payments, the payments that we are looking for, they are being paid equal monthly payments. Okay, so now the payments is equal to monthly, it is 12. Okay, and now for 44 months. Okay, so now we are given 44 months. And then we know that our T is equal to 44, okay, months. I'll write months there, okay. So these two, they imply that your N is equal to MT, okay. What is your M? Your M is 12. Because here this is months, so now you are going to have 44 over 12. That's very important, guys. Uguti, you must convert this T. Your T is 45, so you're going to have 44 divided by T, by the number of the compounding periods of this, which is the months. So now you've got 44 over T, and then this is going to be equal to 44. Mina, I would not even worry about any conversion here, because your time has already been converted to you to be the number of the compounding periods. But some people, they like to calculate things the similar way. If this thing was 44 years, you would have to convert, okay, using the let's say it was I'm looking for an example here. Let's say it was if it was 2 years, for an example, if it was 2 years, you're just going to multiply. But this one has already been converted to 44 months. Okay, an example. Let me just get out and get an example. If you are told that the payments are done, the payments is 2 years, and then they are done quarterly. So you're going to have your M is 4. So now remember, the reason why we are doing this, we've got our N. We want to convert this time, so then it becomes quarterly. Okay, so now we are going to have 2 multiplied by 4, which is going to be equal to 8 quarterly. You are converting that. Okay, but with this one, we are already told what is 44 months. So this is 44 months. It's already been converted to you. So you don't want to be reconverting again. Okay, so you'll be making some errors if ever. You'll be getting into a circular argument if ever you're going to have 44 over 12 only. Okay, so that's what I wanted to highlight. We are looking for our R. So now, okay, this was an example. This is our N is 44. So now what we need to do, what is our I? Our I, it is compounding. Our interest is compounding monthly. So we've got our interest is equal to 0.15. Okay, it is also compounding monthly. So we don't need to be converting anything. The payments are done monthly. The interest is done monthly. So we just go and get our formula. Our formula, it is P is equal to R A N I. What is our P? We are given our P. It is 191,810. We are looking for these payments, which is N. What is our N? Our N is 44. Okay, 44 months. Okay, what is our I? Our I is 0,15 divided by 12. If this was maybe semi-annually, you would have to convert it, but we don't have to. So our R here is just going to be equal to 5693.99. That will be the payments that she's going to have to make for the loan that he wants to take. Okay, so now let us look on the question of amortization. Okay, it's important that you know how to use amortization table schedule, because these are the free marks. Okay, these are the free marks that you are going to get. I don't want to be going through. I don't want to be going through. This is the example that is coming from your notes. Okay, this is an example that is coming from your notes. What I'm going to highlight there is make a way on how to remember. Okay, how to remember these are important. Okay, make a way on how to remember what is the formula of the interest. Okay, what is the formula for the payments, and then the payments you only calculate it once. It is going to be across. So now the payments is going to be coming from this formula that we've just calculated. This will be the payments. So now this will be the formula for the payments. Your interest is just going to be this formula, PRT, okay? And then the principal repaid. The principal repaid is when you've got your payment, you are going to have your payment minus your interest. That will be your C. And then the principal at the end of the year is going to be the amount that you have paid, you minusing this. Go to your notes. Try and recreate the formulas that you would have to remember. Okay, so I'm not going to be taking you through those formulas. I'm just going to do the application. Okay, this example, you can find it in your notes. It gives you a nice way of remembering the formulas. Okay, I want to do application. Okay, so with the application, you've got the amount at the beginning, and then this and that and that and that. So now you are required here to calculate. You are asked to determine the values. Okay, all the values that are not there. That means you are asked to calculate your A. Okay, determine the value of the variables and the applicable interest. So now we are expected to calculate your A, and then your B, your C, your D, and also the interest rate. Okay, so I mean the interest rate, you can easily calculate it. Look here, you can see here, you've got your interest rate, you've got this one, okay? You've got this one. You can see, Guti, this one, the 10% of this is this, but how do you calculate that? The interest, okay, let us start with the interest first, because you are asked to calculate the interest rate and all these things. So the interest rate, it can be calculated by I is equal to PRT. That's the formula that you use for the interest, okay? For the interest you are told is this one. The interest is 1200 is equal to. So your principal for this period, your principal for this period, it is 12,000. What is your R? Is what you are looking for. What is your T? Your T, it is this is yearly. Okay, so if your T, it's just yearly, so you're going to have your T, which is equal to 1. So your R is just equal to 0,10. If you don't believe your calculation for this one, you can also test your calculation for this one. Using the same formula, you will get 10%. So your interest rate is equal to 10%. How do you calculate your A? Okay, you know that your A, whatever is here, is going to be here. So now your A, okay, the formula for your A, that is the amount at the end. Okay, so now we are going to say the principal at the end. This is the one at A. I want my A. The principal at the end is equal to the principal at the beginning. Minus the amount that you have paid. Okay, that is amount paid. After you have memorized your formulas. So the principal at the end is what you are looking for. That is your A. So your A is equal to the principal at the beginning. For this line only, it is 12,000 minus the amount that is paid for that year only. It is 1965.57. Okay, so our A here, it is just equal to 10034.43. So you've got this value and you've got this value. Okay, so if maybe you did not, you could have, this is 00, what is this one? 0034. Okay, so you could have got that if ever you were looking for your A. Okay, you could have got this one, or I want to say or, so then I can give you different ways of looking at this thing. Or here on this A, you know what your I is equal to the principal at the beginning, RT. Your I on this line, it is 1003.44. You don't know the principal, okay? You don't know the principal at the beginning, which is your A. You know what your R is 10%, so you're going to have 0.10. Your T is only for this year. It's not 2 years, ne? Let me emphasize that, guys. You are only calculating for only one period. So your T here is equal to 1 and not 2. That is a common misconception that I found. When someone is calculating for the interest for a specific period, they are writing the number of years that are written here. No, it's only for 1 year. So now your T is equal to 1. So now you find that when you plug this thing into your calculator, your I is just going to be equal to 10,034,43. So this is OR. I am saying OR. Once you've got this, you know it's equal to that. Okay, find the way that you are quick to remember. Okay, it's really up to you on how you see these things. And then what is your B? Okay, you can quickly get your B. Okay, you know that your B can be calculating because you've already calculated your 10%. To get your B, you can say 78,72,30 multiplied by 10%, then you get your B. Okay, if you are not happy with that way of thinking, get the formula again. Okay, it depends how much time you have of thinking, too much thinking. If you are here, this is an interest. I want to change a pen here. You want to calculate this B, you know that B, you are going to have your interest is equal to PRT. The interest at here, you don't know your B here, which is equal to, you know, your principal during this period, it is 78,72,30 multiplied by your R. Okay, your R is 0.10. The period is for this one period, not 3, guys. Only one period. So your T is equal to 1. So you'll get that your B is just equal to 787.23. Okay, so I mean, you don't need to write this formula. You could have just said this multiplied by 10% because you already have your 10%, and then you want to get your C. Okay, to get your C, the amount that you pay back. Remember, what is the formula for the amount that you pay back? The amount that you pay back is equal to the actual amount that you have, cash, chankura that you have. You've got 3,100, you subtract the interest. So from the amount that you have, cash, esesandleni, you subtract the interest, you're going to get your C. Okay, so now your C, it is just going to be equal to 3,165.57 minus the interest that you have to pay first, which is 549.40. So the amount that you are going to be left with, that is going to be the amount that you are going to go and pay your principal, which is going to be 2,616.17. Okay, so that will be your C. Now you need to get your D. Okay, you need to get your D. Okay, when you've got your C, you can get your D. What is your D? It's the amount at the end. You can take lemalile, this one. That's an amount that you are going to go to your principal and reduce it with. So now to get your D, you can say 5,493, okay, minus my C. That means the amount to pay back my principal that I have after paying the interest is going. So that means I am left with 2,616 after paying interest. So this amount, I'm going to go and pay the principal. So after paying the principal, that's going to be my D. Okay, if you don't like that, you could have calculated it by dividing it by 10% by this amount, because this is an interest. You use this very same formula to get this value. Okay, so your D, it is just going to be equal to 2,877.79. Okay, so that will be the amount of getting your D. So there are two ways of getting a D. You can use this formula, okay, or you can use the formula of taking this amount minusing here. So there are many ways of getting around the amortization. So these are the questions, guys. Make sure you get ama-marks of amahalala. The only part that it needs to be problematic about amortization, because you have to think there. Okay, let us look on another example. Okay, so this example is a schedule for Fred's home over a period. Okay, this one, what I want to highlight is when you see this thing, it does not mean you are going to be putting 196 in your formula. This is for one period, okay, and it's monthly. You are working with months, so you know what your payments are made monthly. Okay, you've got monthly payments, and then here you are asked to calculate for your interest. Okay, so your interest, you know, go to your interest formula is equal to PRT. Okay, so what is your interest? This is your interest, which is 8,690.04. What is your principal? Your principal is 948,004. Okay, what is your R? That's what you are looking for. What is your time? Your time is okay. Your time is monthly. You've got months, so it's only for one period. So now you are going to have 1/12. Okay, because it is monthly, it's only for one period. Okay, someone is going to ask Guti, what happened here? This is here for one period. You are having 1 over the compounding periods. So your T is 1 over M. That is a formula for your T. How many compounding periods, how many, this thing is made yearly. So our T here was 1 over 1. That's why we're working with 1 across, okay? Here, if you are going to use the same formula for T, so we are saying our T is equal to 1 over M, okay? Because our compounding periods here, it is equal to 12. Why? The payments are made monthly, monthly. Okay, so therefore our T is equal to this. If ever the payments were made quarterly, you are going to have 1/4. So your T was going to be 1/4 for each and every time period. So remember this formula when you're doing amortization table. I'm highlighting common misconceptions in these questions. Okay, so our T is 1/12. Okay, so once you've got that, you rearrange everything, you find that your R is equal to 0,11. Okay, so now that will be your R. Okay, and I'm sure the following question, I don't want to move to the next slide, but we need to calculate our A. Okay, so now you can calculate your A, okay, without going to calculate that formula amortization. You know, would see your payment once you've got your principal. You've got your principal that is paid. Okay, the amount that is paid, okay, is equal to the payment. That is the formula. Is the payment minus the actual interest. Okay, that is the formula. Where do you get that formula? You would get your formula here after you have memorized it, because it's not going to be given to you. You just need to memorize these different, your E, your B, your A, your C, your D. Okay, so now your principal that is paid, you are told it is equal to 17,114,67, which is equal to the payment you don't know, that's what you're looking for. The interest is 8690,04. Okay, so your A is just equal to, your A is equal to 25,804,71. What is a common misconception here is when people would say your time is 196, and then they will go and take it and divide it by 12. That is a common misconception. Okay, so it is not about what you see here, it's about the payment periods. Okay, how do you get your payment periods? You use this formula. For each period is 1/a payment, which is the same, because we're looking at equal payments. Okay, so the answer here, this will be the question, that will be the answer. And here is another question. Okay, this is a question whereby you've got Joseph bought a house. He managed to secure a loan at an interest of that amount per year, compounded monthly for a period of 20 years. His monthly payment is this amount. Okay, determine the size of the present value of the loan. Okay, so here let us write what we are given for A. Okay, what you are given for A, you are given that your interest is equal to 0,12. Okay, you are told what is compounding monthly. Your M is equal to 12 for a period. Your T is equal to 20. What does that imply? That implies that your N is equal to MT. So your M is equal to 12 multiplied by 20. Okay, which is 240, I guess. And then you are told what his monthly payments. So now you've got the payments of 17,307,17, and you are happy. Your payments are monthly, so your payments are monthly. So when this is equal to this, you are happy. Otherwise, if they were not the same, you will have to go and convert your interest rate so then it compound the same period as your payment. So you are happy with that. So you are looking for your present value. Okay. So now to calculate your present value, to calculate for your present value of your loan, your present value of your loan, remember, is equal to RANI. Okay, so which is equal to your R is 17,307,17 A. Okay, what is your N? You've already have your N here, which is 12 multiplied by 20. You've got 12 multiplied by 20, which is 240. Okay, so this one is 240. Let me write here so then when you go through, you can see where we get our 240. This is 240. Our I is 0,1275. We are going to divide, remember, we are going to divide by 12. Okay, so our present value of our loan, the present value of our loan, it is just equal to 1,5 million. Okay, so now that's what you have. That's the present value of your of the loan. Okay, but with this present value of the loan, we do not know. Okay, we need to calculate now. That is the question that they were asking for. We are done here. Let us look at number B. Okay. Let us look at number B. Number B, you are asked to calculate the real cost of the loan if the average inflation rate is 6, per year is expected. So now there is an inflation and then you need to calculate for the real cost. So what is the formula for the real cost of the loan? Okay. So remember the total real cost, the formula is saying the real cost of the loan, the real cost of the loan is equal to the present value at inflation minus the present value of your loan. Okay, which is this one. This is the present value of your loan. Okay, so now to get the total, the real cost of the loan, we already have this part. Ne? We already have this part, but we don't know this part. So we need to calculate the present value at inflation. Okay, so now to calculate the present value, we are going to be using the same payment. Nothing has changed. The only thing that has changed for present value of the loan is the interest, which is an inflation. So now we are going to have our present value at inflation is going to be equal to RA NR. I'm going to say R because it's different. The time is the same, but the R is the inflation rate. So our R is the same value. We've got our R, which is 17,307, 17 A. The period is still the same. Okay, it is 240. We've got 240, but remember, we are looking at an inflation rate of 0,069. Okay, so now you've got 0,069. The inflation rate, it is going to be doing the same thing. It's going to be compounding the same period as the interest rate, which is, it is monthly. Okay, so now we are going to be dividing by 12. Okay, so now the inflation rate is going, it is behaving the similar way as the interest rate. like the compounding periods. It cannot be doing its own thing. If ever the inflation rate is doing its own thing, maybe semi-annually, you would have to convert that semi-annually to become the same. It must behave the same way as the interest rate. It must be compounding the same periods. So you'll have to convert. So now your answer there, your present value at inflation is going to be equal to 1419229.52. Okay. Once you've got the present value at inflation, now you can go to your formula. So you've got your formula. Okay, so here is your formula. You come to your formula, you plug in. You've got your present value at inflation, which is this one. You are going to subtract the present value of your loan, which was this one. You subtract and then you get the real cost of your loan. All right, so what we are saying is the real cost is going to be equal to the present value at inflation. It is going to be 141,922.52 minus what is the present value of your loan? It is that 1.5 million, which is 1500003. So your real cost of your loan is going to be nothing other than 229.50. Okay, so now that's how you'd get the question on the real cost of a loan. Let us look on another example. Okay, you've got this question. Okay, this question, Levi buys a house and manages to secure a home loan. So this is the home loan I told you. Okay, so he gets a home loan of 950. That is the present value of his loan. So your PV loan is given here with a monthly payment. You are given the monthly payments, okay, at a fixed interest rate of this amount. This is compounded monthly, okay. So we are happy the interest rate is compounding the same period as the payments over 20 years. Okay, thank you. The story is straightforward. Okay, if the average inflation rate is 6.8 is expected, then the real cost to the nearest rent of the loan is approximately same thinking. Okay, same thinking as we have done. Why are you leaving me alone like this? I'm looking at another example, so I'm sorry for that. So this will be the present value of your inflation. So this is going to change. Okay, so you are going to have 2249,706,809. It's nice to put these things with so many decimal points, especially if ever you are going to be answering questions as in a lento with multiple choice questions, because you want to get closer to the answers. So that's why you'd ask, good, why do you have to put so many decimal places? It's helpful. So then you can get the answer that is similar to what is there on the multiple choice. So that's why this one, at least you leave it 3 decimal places or 4 decimal places, really up to you. But make sure that you've got as many decimal places as possible, especially when we are looking on the questions of because there are so many calculations, there are many layers. So it's important that you at least you keep maybe 5 decimal places. So now that will be this question. This question can be dealt with. This question can be dealt with in the similar way. Okay, I don't really want to be spending time on this question. I'll come back to this question. Not it's the same as that one, but I'm looking at the time. Okay, I'm looking at the time. I just want to share something with you. Then after sharing something with you, I will because it's too late to start the bonds now because it's already 22. The next session is just going to be clean. I'll be doing all the exam related questions on bonds. The next session, which is going to be our last session. So bear with me. Next session, when you get an advert, you must know we are going to be looking at bond related questions. We're going to be getting different exam related questions on bonds. So I'm not going to be looking at bonds today. The one for data handling, we will look at it if we've got time. Okay, so let us look at this question. Ne? This question basically what it's saying, it is saying you've got this lady who has bought a house, okay, bought a house and made a down payment. I'm interested in these questions of down payments because I've been looking at your exam question papers. There's always the question about a down payment. Okay, Susan has bought a house and then made a down payment of 40% of the price of the house. You've got the price of the house. She managed to secure a loan. There is a loan for 20 years at a rate of this, which is compounded monthly. Her monthly payment is this amount. So now we need to find the down payment. Okay, let us break down all the features of our example. Okay, so let's look at what is it that we know. Okay, remember, if ever you're making, you're looking at the payments, you need your present value. Let us break down what you are given. For these questions, you need to have your present value. You don't know your present value. Okay, you are told that the time is equal to 20. And then the payments are made monthly. So your M is equal to 12. So these two, they imply that your N is equal to 20 times 12. Okay, which is 240. Okay, that's what we know. We know that the interest is equal to 0.13. And then it's also compounding monthly. We are always looking for those things before we can even start. If this is equal to this, then we are happy. We don't need to worry about converting anything. And then we are told that the R is equal to 7026.92. So that's the information that you are given. And then you are told what this person has made a down payment. There's an amount that they've put, and that down payment is given to you as a percentage, which is 40%. Okay, so now we want to get the present value of the loan. Okay, so let us first before getting the value. Okay, we are only given the percentage. Okay, of the down payment. So now we need to first, before we can get the actual down payment amount, we need to first calculate our present value. Okay, let us calculate our present value here. Okay, so our present value is equal to RANI. We know that our payment, it is 7026.92. And then our time is 240, and our I is equal to 0.13. And then this is compounding monthly is 12. So the present value here, it is equal to the present value. Let me see if I've got correct things. The present value is equal to 58199, I'm going to leave it to 4 decimal places. Okay, so now we've got our present value. Okay, so now for us to get the present value, we need to get the amount of ilento, the down payment amount. Okay, so for us to get the down payment amount, we need to know what is an actual a cost. How much is this house costing? Okay, the actual value of the house, the value of the house, that is the house price. Okay, we don't know the house price, so we need to know what is the value of the house price. Okay, so then we can subtract from these, okay, the percentage of the down payment. Okay, so then we can get the actual value that the person has paid the amount with. So now there are formulas that I'm going to share with you. I think you can just memorize them or try to remember them. It will depend on the context that you are given. Okay, for the down payment, here are the formulas if you are given down payment. So now you know that your house price, uh, um, 1 minus down payment percentage, né? Down payment percentage, the actual percentage, this is going to give you the present value of your loan. Okay, that is, what is your present value of your loan? This amount, this is the amount. Okay, so you've got your present value of your loan, okay, to get to your house price. Okay, so now to get the actual down payment amount, you've got your down payment. You've got your down payment is equal to the house price minus your PV loan. Okay, so now these are the formulas that are going to help you when you get questions which are talking about the down payment. Okay, make sure you remember these loans. So here we are looking for this. Okay, we know a PV loan, we've just calculated it, but we don't know what is a house price. Okay, we want to know the original value of this house. Okay, because now the value of the house does not equate to the loan that you got. Okay, sometimes you can get a loan, and with this person they've already put some deposit. Okay, so now we want to know what is an original price of this house. Okay, then after the original price we are going to subtract the down payment, so then we can get the actual loan, which is this formula. So now we've got these two formulas. So before we get the down payment, we don't have a house price, but we can get the house price from formula number 1. Okay, so now let us first calculate let us calculate using this formula first. Okay, so now we know Guti, our house price is 1 minus down payment percentage. It is 40%, which is 0.40, okay, which is equal to the PV loan, the present value of your loan. It is what you've just calculated, which is 58,199,999,9558. 9558. Okay, so now you can manipulate everything and get your house price. So your house price from this formula, it is just going to be equal to 969. Okay, it is 969.99,1996. Okay, once you've got your house price, now you can come in to this formula, okay, to get your down payment. Okay, so now to get your down payment, so now your down payment, the actual amount, not the percentage, is going to be equal to, substituting in this formula, your house price, it is 9699, 1996, you are going to subtract your present value, what you have calculated, which is 58199,9558. Then the down payment amount is going to be equal to 388,000. Okay, so this will be the down payment. So what is important in questions of down payment? Try and remember this formula. It will make your life easy if you remember this formula. Let's see if ever there is no other question which is looking at things like down payment. Yes, I've got another question which is looking at down payment. Yeah, this one. Okay, I came across in one of your exam question papers. You've got this guy wants to buy a townhouse that costs, this is a present value of the townhouse. No, it is a townhouse. It's an actual value, not the present value. Remember, the present value is when you go to a bank. Okay, is when you go to the bank, they tell you, Tina, we are not going to be able to give you this amount. So maybe they can give you more, or they can give you less. So this is an actual cost of, it's a price of a car. It's a price of a house. So here you are given the house price. So the house price is equal to 200,000. That's what you are given. After making a down payment of 20%, you are given a down payment percentage, okay, of 20%, okay. He manages to secure, now he goes to the bank and secure a loan for 20 years. So the time is equal to 20 of the loan from the Nursery Bank at an interest rate. You are given this thing is for 20 years at the bank interest rate. So the interest rate is equal to 15%, which is 0.15. This is compounding monthly. We are happy. And then the payments are being made monthly. So your M is equal to 12. This implies that your N is equal to 20 times 12, which is equal to 240. Okay, so that's what you have here. And then they are looking for UR. You don't know your R, but for you to get UR, you still need to get your you need your present value, but you don't even know the present value. Okay, the only thing that you know is this information. Okay, so you'd have to go through the similar formula because you saw that you've got izinto zaboma down payment. What you'd have to do in this case, you say, let me manipulate this information. What does it help me? This information. I need to work with this information so then I can get my present value. Okay, remember what is our formula for if you've got a house price and a down payment, a formula. We know that the house price is 1 minus down payment percentage. Okay, down payment percentage, which is equal to the present value of our loan. Okay, so we know our house price is 200,000. 200,000 into 1 minus the down payment percentage, it is 0.20, which is equal to PV loan. Okay, so our PV loan is whatever, after you have done your calculation, you'll find that your PV loan is going to be equal to 160. Okay, 160,000. So now that you've got your PV loan, now you can go now and calculate for your R, because you are asked to find your R, not your PV loan. But you discovered that your present value of your loan, you did not know it. But here you are only asked for the monthly payments. You know that your PV is equal to R A N I. Okay. So what is your PV? Your PV is 160,000, which is equal to, what is your R? Is what you are looking for. Then you are going to have your N. Your N is 240. What is your I? Your I is 0.15. This thing is compounding monthly, 12. So therefore, your R is just going to be equal to 2106.86. Okay, so that is how you can manipulate the questions whereby you are working with AMA down payments. Okay, so it does not matter how it is been presented to you. What is important, remember these formulas. These formulas will help you to just get 100% on the questions that are talking about e-lento, the questions that are talking about down payment. Okay, so now make sure you remember this question. One thing that I also want to highlight in these questions, you definitely, okay, the recourse of the loan, I've taken you through on the formulas that obviously you know. What I want to highlight, I just want to highlight the misconceptions. This formula, remember it when you are working with AMA-lento, amortization schedule. You will get a question on amortization schedule. But make sure that you know the formula is 1/m, and you don't put 196. It is one period over the compounding periods, which is monthly. That is going to be the same for all the periods. Each period is going to be 1 over the compounding periods. So that is an highlight that I want to make. It's the common error that people always make, and then you find yourself that you are losing marks on things that were just free giveaways. Okay, I expect you to have issues with AMA bonds because there's a lot of thinking there. But with these questions, you should be like swimming, just flowing. Okay, so this is the end of our session. This is the end of what I thought was useful to help you with your exam preparation. I wish you good luck with your preparation. As long as we are still available, please use us.